Hello everyone. Things can't always go completely according to plan. And this time, I'm afraid I have to admit I kinda messed up. This ROM programmer is intended to be physically capable of burning most ROMs of the 24, 28, and 32 pin varieties, and it does a great job at burning most of those. It's probably the cheapest way to burn a pretty big range of 24 and 28 pin ROMs like these when I think of it, which is a pretty big success in itself. And it is physically capable of burning a lot of 32 pin ROMs too, at least partially. You see, when I designed the programmer, I really only had 5V programmable 32 pin ROMs in mind, like the modern flash ROMs, and electrically erasable ROMs that require both 12 and 14 volts in an erase and program sequence I hadn't really considered. Said another way, if you want to program large 32 pin ROMs that require 12 and 14 volts with this programmer, you might run into issues. If we take a look at the schematic for the control signals, some of you might already notice the issue. Since I was starting to run out of I/O pins, I decided to share one of the control signals with an address line. Specifically, I have the signal that controls changing the voltage from erasure voltage to programming voltage hooked up to the same pin as address line 16. For 5V flash-based ROMs, that's not a problem at all, but unfortunately that also means you can't change A16 without dropping the programming voltage about 2 volts. This means programming 32 pin ROMs with more than 64K of data will give unpredictable results. So I'll be sure to fix that on the next PCB revision. Of course, I have a feeling most people are interested in this programmer for programming 28 pin ROMs like the typical 32 and 64K ROMs, but since the goal is programming as many different ROMs as possible without increasing cost, this upgrade is certainly worth it. And since over 100 people have already bought one of these from my one-man shop, I'd like to show how it's possible to fix it with a little bit of PCB surgery, making it possible to program up to 4 megabit 32 pin ROMs. So let's give that a go. To undo my blunder and make it possible to switch A16 without affecting the regulator voltage, the easiest way is to cut it, and then use something else to switch A16. I promise we'll get back to that. Since we want to leave the regulator control signal intact, we don't have a lot of options when it comes to snipping the connection to A16 on the socket pin 2. And unfortunately, it mostly runs on the top layer, meaning it would have been a lot easier to do before mounting the SIF socket. On the 3D view in KiCad, we can clearly see it's pretty easy to run a scalpel through the trace under the socket, but since the socket is already mounted in my case, and in yours too probably, we're limited to this tiny area between resistor 19 and resistor network 8. But at least there is a place to cut, even if most people will have to grab some magnifiers to see the trace in real life. Luckily, there aren't other traces running too close to the target, so with a little bit of patience, I can just run the scalpel along the socket a few times until I'm confident the trace is cut. With that out of the way, let's get back to how we're going to drive A16. The thing is, we don't have any more I/O pins left over, at least not on the 65 Arduino that only has 2 I/O ports and no analog pins like we'd find on the Arduino Uno. So we'll have to repurpose something else. We're in luck though, since I noticed that only 5V ROMs have address line 18 on pin 1, whereas 12V ROMs usually have VPP on pin 1 and address line 18 on pin 31. And since we only need A18 on pin 1 when the high voltage regulator is off, we can simply toggle VPP on pin 1 to control A18 instead, freeing up an I/O pin we can use for A16. It does mean A18 on pin 1 won't quite get 5 volts, more like 4.8 volts, and only has a pull-down resistor to make it go low since it's powered through a diode and a transistor, but that's a hack I can live with, especially considering it's usually the address pin that changes the least often. The easy way to disconnect A18 from pin 1 so we can use it for A16 is to simply remove the diode, Or if you're not a brain surgeon by day, just go ahead and utterly destroy the poor thing like I just did. It's okay, we won't need it again. For the PCB revision though, I will probably connect the pin 1 VPP control signal through the diode to avoid some of the voltage drop. With both old signals disconnected from pin 1 and 2 of the socket, we just have to put a jumper wire between the signal named A18 to pin 2 of the socket where we have A16. Since I might need some of the other signals on the address and control line breakout header later, I decided to solder the whole header before hooking up the jumper wire. Another little hack about the jumpers is that if you have JP3 configured for 32-pin ROMs with the solder jumper, you don't actually have to change and resolder it to program a 28-pin ROM with VPP on pin 1. What I do is simply add a jumper wire to the SIF socket when I program 28-pin ROMs, since a 28-pin chip doesn't care about the pins it's not connected to. And putting a leg from a through-hole LED is just as easy as putting in a jumper. Certainly easier than redoing the solder jumper. If you don't think you'll be using the programmer for any hacks though, I wouldn't recommend soldering in the whole header row though, as the first few pins will short to the USB-B socket shield on the Arduino Uno, which is no good. So you have to add your choice of insulating tape if you do solder in the header pins for the control register. You probably don't need the tape if you don't solder in the pins though, but it is pretty close even without the pins soldered in. At the time of this recording, the 6502 firmware for the 6501 doesn't support ROMs over 64K, and neither does the proof of concept code I wrote for the Arduino Uno. So for this little test, I had to modify Henrik Olson's Firestarter firmware for the Arduino Uno a bit to get it working with this fix. But amazingly, it does work, and the programmer is now happily programming a 512K ROM without issue. I have a feeling that by the time this video is released, Firestarter will fully support this hack of moving A16 to a different pin, but I'll be sure to update the video description with what firmware you can install to get the most out of your programmer. If you don't have a programmer yet, but you'd like to get one, I'm sorry to say I'm all out of stock. So if you order one from my shop right now, you'll actually get a revision 2 board with this fix already there. Unless something goes horribly wrong, I also expect the new board to have less jumpers and be able to switch the pin count of the ROMs in software without moving jumpers around. I hope to get the new boards in about 2 weeks. In 2024, I know it seems a bit silly to be excited about sending half a megabyte of data to a DIP chip that requires 14 volts to erase like this one, but I hope at least someone out there gets some real-world use out of it, and just maybe keeps some old hardware out of the landfills. Either way, thanks for watching.